Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow guys, all that aside, let's get on with the show. All I'm going to say is this was a rough weekend. Have you ever wanted something to work so bad that you were just like ass over feet, head over brain? I'm going to put money in this and time into it. I don't care. I want to make it work. Well, that's where I found myself with the Henry. I just had to set it aside. I'll give you a clue, a little tidbit. There's a video on this coming, but all I'm going to say is this transformer right here is the bane of my existence. There is your primary plate transformer, and then it takes this voltage and it dumps it into a set of diodes. And out of that set of diodes, before it goes up to the main electrolytic source for filtering, you've got this, quote, smoothing transformer. I've had 3 or 4 people refer to it as that, although they tell me, that's not exactly the right term. I'm like, okay. This transformer here is 8 Henry 770 milliamp transformer. And as far as I can tell, it knocks down the secondary voltage on the transformer a little bit. And it is designed to help take out some AC ripple, but there's some inductance principles that take place here. And because this sits between the rectifier bridge and the primary plate transformer, it also acts as a load buffer. I'll get more into this later, but needless to say, I had smoke and flame and fire and shit flying out of the end of this thing. Okay. That's then, this is now, let's focus on the task at hand. This Henry so far has taken a set of tubes, had to go out and find a set of chimneys for it. IMAC chimneys, which, come on, in this day and age, and now I've got an actual match set of IMAC chimneys. I'm not kidding. Right here. Real deal, old school. I probably could have IMAC SK 4.6s. Technically a little bit too tall, but perfect. Went out and found a set of chimneys for it. I don't know. I just want this amp to work. I have faith that I'm going to make it work, and now I'm on the hunt for that filtering transformer. Anyhow, right now, my goal is to look at this RM Italy kl-500. I've never been a fan of these. Never, not once. If anybody's interested, I've got a kl-500 that was literally abandoned here. The customer that owned this thing sent this thing out to me to get it repaired. The preamp is in-op in this thing, but it was so overdriven that the entire input circuit was burnt up. The keying circuit was destroyed, which is actually up here in the front on the board. And I managed to make it all work with a different keying circuit in a different location. Got the low, medium, and high to work. Got the FM and sideband to all work again. Got the on-off to work all again. And I went back to him and I told him the repair bill on it was just a few $100s. Because I know these amps aren't really worth a whole goddamn lot. And he told me that was, and I'm quoting him now, that's way too much money because I can find one for way cheaper on the internet. So it lives here now. I'm not a big fan of these things. I'm really not. They are what they are. These are made, of course, in Italy, supposedly. These are printed circuit board slime line production amplifiers, to put it mildly. They barely work at what they do. The heat sinks on them are woefully inadequate to do the job. We got 4 transistors on a, maybe just a little bit over a 1/16 of a bed of heat transfer heat sink. And then on top of that, we've got these finned but anodized, which makes it conduct heat just a little bit better surface. But every one of these I've ever come across, we always end up putting a fan on top, and it seems to make them last or run a little bit better. This has got 6-stage variable. 6 is high, 1 is low. We got your on-off switch, preamp, and your TX indicator and AM and sideband. I don't know what my buddy's into this for, but just take it easy. He wanted me to upgrade this. He wanted me to put 2879s in it. I said, why? God, why? You're going to spend more money on the transistors than what the amplifiers were. And he's like, well, how much improvement will it make? And I said, very little. And I said, on top of that, then I got to go and change the windings on these already hard to deal with transformers. I'd have to change my capacitance on the outputs. And it not worth it. So he said, okay, just go ahead and check it out. Make sure it works. There's a couple things I take issue with, like these pins here are jumpered together with a twisted piece of wire. So we're going to go ahead and we're going to solder those over. And then we're going to get rid of this pathetic power wire. And we're going to bypass these little glass fuses. I found that that makes a huge difference in how these run. As far as temperature goes, there's not such a current restriction. If you go and you sit there and you run this, of course your transistors are going to get hot, but these fuse holders get so hot that you could like cook eggs on them. Well, I live in a fuseless universe. Okay, if you're going to do something, put a big breaker on it, be done with it. But I mean, if you absolutely have to. Let's run through the functions. Let's turn up the receive on our 2950 here. Let's turn this thing on. Horrible noise floor on the transistor, but it is working. It is working. So let's go ahead and we'll turn this off. We're going to show you pass-through tune first. Which isn't too bad. And so we don't have to pan back up here again. 1 2 1 2. That is our whole input tune. Hold on to your undies. That's what it is. Nothing. So from that standpoint, we're good to go. We're in golden conditions as far as that's concerned. Okay, so let's go over here to the Albertos and let's see what the truth-telling machine tells us. So we got our 1000-watt slug in the peak hole, 1000 in average, and of course over here in the corner our 5-watt coaxial dynamic slug in reverse back from the bird 10,000-watt dummy load, which when everybody comes over here and sees it sitting underneath the workbench, they're like, my God. And I'm like, yep, it is what it is. Okay, so in all fairness, there's our 20 whole watts of power. So stage 1. Stage 2, very little difference. Stage 3, 250. Stage 4, 250. Stage 5, 250. And stage 6, 300 watts or so. Wowzers, Inspector Gadget. 1 2 1 2 1 2. Okay. Now, that's the way the book says this should be run. Me, on the other hand, I digress. Come here. So let's see. It should do 500 watts. Give me the black coax. Black. Okay. Now what I'm doing over here that you guys can't see because I'm out of frame is I'm going to hook up the 955 radio. Radio inside the studio. Let's see what this makes it do if we hit it with about 80 watts of power. Make sure our stage is all the way open. Hello. Wow, hold on to your undies. Wow, that's a lot of power. I don't know if you guys are going to be able to handle this. It's gobstopping. Hello. Hello. So we tripled our drive from 20 to 80 watts, and it makes about 20 whole more watts of power. So, hello. Wow. Hello. The average needle's falling in reverse. Okay, let's do a little power wire modification to this, but this is working basically as we'd expect it to. We're going to solder this in. We're going to change out our power wires, which are now hot. Our fuse holder, which is now hot. We'll get rid of these wire nuts, which are now warm, obviously. And let's see what we get. Just because I don't like something doesn't mean I'm not going to give it a good honest effort. I just sent a customer a picture of this thing with a fan on it. He's probably like, oh wow. Got to tackle everything in life the same. Got to give it a good honest effort. You can't just, oh yeah, I hate this thing, it's a piece of shit. You can't act like that. You got to grow up when your little man bag drops and you get a little bit of fur around your your man sausage. You gotta just kind of go forward with a more even keel. So we went ahead and we put ourselves a quiet little fan on top to maybe give this amplifier a prayer of lasting. Went through and made sure everything was tight as far as the screws were concerned. Did a very mild power wire upgrade to this thing. We completely bypassed our fuse holders over here, so the power wire, the positive, comes in now, goes through our wires directly to our transformers. Now, I don't want to say the power wires are the main reason that this is doing this, but just saying, this is the results. Same radio as before, 2950. Hello, audio. Same amount of drive. We're going to start out in position number 1. Positions! Alright, position number 1. Hello. 2. Hello. 3. Hello. 4. Hello. 5. Hello. And 6. Hello. Audio. Works way better my way. Way better my way. With the 955 hitting it, it makes 425 watts. There's not even enough improvement there for us to go and talk about it. Our input tune's good. Output tune's good. It's making reliable power. We're done. We're not going to get any more excited than that. You're not going to, I don't have any crazy ideas. Now, I wonder what happens if we rip the output transformers out, change the bias circuit, change the input circuit. No. I can't spend very much time on this because the box is worth nothing. Zero. Nada. Zip. Zilch. If I come back to him and say the repair bill on this little section of the thing is more than just maybe $100, it's not even worth sinking the money into it for it, because you can go replace it for cheaper than that. I'm just saying. Fact. Not opinion. The fact. So by making sure everything was tight first, and bypassing the fuse second, power wire upgrade third, we picked up 100 watts output power. 100 watts. 100 watts. That's a 1 with 0 and a 0 on it with the output power, and our heat dropped way off. Okay? So I'm going to slide the tin back in this, and we're going to continue on to this other thing that I think is very interesting and I'm looking forward to working on. I don't know how to classify this. I don't know. According to this piece of paper on top, this is a mobile HF amplifier. 10 meters equals 10 meters through 160 meters. 80 watts max input equals 400 watts output. Ready? Big reveal. Looks just a lot like a ss750, or I can't remember the name of the company that sells these boards right off the top of my head. But I'd be hard to argue that this is some kind of project amplifier. But then when I look on the back here, we go and we look at this tag. Made in USA, RF power amplifier, the TE systems, and then it's got this number right here. So this was a type approved piece of equipment, supposedly. It's got a model and a serial number, but they're blank. Everything in here is screen printed. This isn't a repurposed heatsink. This is a high power amplifier. Let me turn this around. We've got amplifier in, amplifier out of line, or otherwise on off. Preamp, which that circuitry is not even in here and we're not going to add it. FM, and then CW sideband mode. This is an afterthought, this switch. So it's supposedly got temp, RF indication, and remote indication on the front. TE Systems high power amplifier, ECHO. Now on the inside, we've got his 4 Toshibas. They are non-red dots. They are worth more than the amplifier completed. $200, $400, $600, $800 in those 4 parts. So my mission here, as I was informed on the phone here early this evening, was this 80% complete. You just need to make it so it turns on and off. Okay. I'll go with that. If I have to. A lot of the little finish work in here, like, let's fly you down into this and let's go take a look at it. Amp Systems of America. Just popped in my brain. A little kind of scuzzy on that connection, but we don't need to worry about an input tune when we've got an attenuator. That's how we can get away with hitting this with so many watts. This is input and outputs, but this is your input splitter. This guy here. This is your output signal path. That goes to here and to here on the board. These are your bias control points, which you never, ever, 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 ever want to touch, ever. You have your positive and negative rail feed points, okay? And then we have our output side, which is over here, with a flat output flat output tuned response. There is no filtering in this. There's no low, there's no high, there's no notching, no nothing. And basically what we have is a blank on-off circuit in the front. One LED indicator resistor, and then an on-off switch. Now, what I think is interesting is this on-off switch comes over here, attaches to the relay. It's a manual key, which is cool. I get that. But where's it pulling his 12-volt signal source from? Two wires here, 2 wires here, and they go directly down to the boards. There's an insulator on the positive side, which is here. There's nothing bringing 12-volt current to the switch. And then in turn, this wire here goes off, goes underneath this board, right here. Sorry, gotta go over here. Sorry. There's nothing bringing 12 volt up here. Nothing. So we can take a, have to pop off one of the positive wires and bring over here and come to the switch. Give ourselves a source send, which this is all wired wrong. This shouldn't even be hooked up. This wire, it goes around and it comes over here, and this is what attaches to our bias. I'm assuming they attach through, and that's what turns our bias circuit on and off, which we've got to have that switched. Otherwise the thing will melt down into refried dog doo-doo. Okay, so it continues all the way through the board. So this is going to be our bias switch point. Actually, it should be, in all fairness, here on the board. But we'll utilize here. It means this board's going to see the switch current for bias last, but we're splitting hairs there. So I guess I can sneak a screw in here, right here with an eyelet on it for ground for the LED indicators, so at least we can make it glow up for them a little bit. The preamp is going to be in-op, completely in-op. I guess this was just some auxiliary 12 volt source or switch or something. We're going to get rid of all of that. And then without mucking around with the tuning or anything, we just want to achieve basic operation, which is going to be wiring and switches. I want to see what it does. I want to see what kind of response that we have across the spectrum of things. We'll look at it with the analyzer first, and then we'll actually do a run load on it and we'll see what it does. This is going to be interesting to see. To me, very interesting to see. So let me get all this wired up and buttoned up, the front end of it. We're going to have to add a second relay for our bias control so we can turn our bias on and off. Otherwise, all of this fancy schmoo, and then pray the boards were assembled properly, which they look like they're okay. This is going to be interesting. I'm kind of interested. So here we are. Fast forward 3 hours, and got our bias relay put in. We've got it all wired, so we got the appropriate on-off. We've even got transmit indication LED, which is real dim, but it's there. We're running on 14 volts, 1000 watt silicon peak, 1000 and average 5 watt silicon reverse. We're using the ICOM 7300. Now, I'm going to say this once, and you're just going to have to assume it's fact. But it makes no difference for me to keep panning up here and showing the input reflag, because the input is hidden behind an attenuator. This 3 dB attenuator right here. That's the only thing the radio actually sees. This could be an effed up train wreck on this side of the attenuator, and we'll never know unless we bypass that attenuator, which we don't want to do. And you're going to see why here in just a second. Okay, so we're on 160 meters at the moment. Blowing my mind this actually works. Technically, we are outside of the coaxial dynamics elements, their range. So we're right at the very edge of it. We're at 1.6 megahertz, and this is 2 through 30 megahertz. We're right at the very edge of it. So we're at 1.9 megahertz. So we're close enough, but technically we're outside the bounds. Okay, we're on sideband, and I'm going to show you drive. Hello. So we're going to put 80 watts into this thing. Now let me step on my foot pedal here. Hello. Audio. I'm making 630 watts worth of power. Now really, for some reason, naturally, this amplifier likes 80 meters. Really does. So let's go ahead and we're going to jump to 80 meters. 3.8, 896. We're also on sideband. Step on a foot pedal. Hello, audio, hello. 1, 2, 1, 2, hello, 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 hello. Let's go up here. Let's take a quick look for our input tune. Remember, when we're looking at the radio, we're looking at the SWR bridge, which is the second line down. Hello, 1, 2, 1, 2, 1, 2, 1, 2, hello, hello, hello. Okay. So we're getting 600 watts out. Now, we're going to go ahead and we're going to jump on over here to 40 meters. Okay. Hello, 1, 2, 1, 2. Ah, we're on AM, that's why. Sideband. Sideband, please. Hello. Okay. Those are 80 watts of drive. Hello, audio. Hello, audio. It's also very happy on 40. Very happy. So, this is where we're going to start turning around and we're going to see the return side of the curve. So without us adding inductors and capacitance on the input and the output portion of the network, this is where we're going to start seeing diminishing returns going forward. Okay, so let's go ahead and let's jump to 20 meters. Hello, audio. Same drive. Hello, 1, 2. Shocking, isn't it? Now, because there's no filtering circuits that are in place in this amplifier, I have advised the guy that actually owns this thing that you have to run a low pass filter. It has to be done. Has to be done. Now, our input network is very smooth on the meter on the outside, and I can almost guarantee that the input network is falling way out of resonance, and so is the output network. So without us adding our extra low and high pass cut filters, plus then adding the extra inductors with the extra capacitance, like what's inside of the ss750, which is, that's what I've got to work on next. I'm here to tell you, we're going to start seeing diminishing returns as we go up in frequency. Okay. Hello, audio. So that's where we're at here on 20. So let's go ahead and we'll jump up here to like 15. Just to give you an example. Hello, audio. Here we're on 15 again. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, hello. And now we're going to jump all the way up to 10, which I have no idea what it's going to do because I haven't bothered testing it because I don't really care. All right, 1, hello. Hello. Now we're at 300 watts. So we've lost half of the amplifier's output potential because of no tuning circuitry, which I am not commissioned to install. We've got our bias set at a nice smooth half, 500 mils, which is perfect. Leave it alone. Do not touch these two potentiometers. Actually, you know what? No touchy. No touchy. Just keeping the honest people honest here. That's all we're doing. Because somebody with a screwdriver can get in there and adjust that if they want. That takes the liability off me. Okay, so let's cover up our LEDs on the front. The rest of the circuitry is not in here, so we left this in op, and the rest of this stuff is not attached as well because we don't have that circuitry. I asked him if he wanted me to build him a remote. He said no. So he's planning on running this thing on 80 meters. Well, we got lucky because it's naturally resonant on 80 meters. Okay, well, I'm done with this. Now let's go revisit something that's been here for entirely too long. I don't know if you guys remember, there was an ss750 made by Henry that came through here that had the full-up band board in it. And I did a huge YouTube video about the band board, how it changed resonancy, how a stepped, if we're looking at things as a 0 being here on a frequency and 30 megahertz being here on a frequency, how that band board would take and make a low pass notch, or pardon me, a low pass filter and then a high pass notch. And so it only let certain segments of RF through, which I thought was brilliant. I was very impressed with that amplifier. It's an 8 transistor device. It makes 700 to 1000 watts everywhere. It's got the same band board that's in the Metatron. Metatron's another amplifier I'm very impressed with. It's another 8 transistor device, usually makes about 800 watts, somewhere in there. Which is kind of not that surprising when you're tuning the circuit for the most flat response that you can give to it. You're going to see only about half of the transistor's potential uniformly. So it's like when guys, back when I was actually taking orders way back when dinosaurs roamed the earth, you know, pterodactyls are still flying around, that kind of thing. Guys that asked me, can you build me an all-band amplifier? Yeah. Well, can you make it do 2,000 watts? No. You can't. You can't get the transistor to respond uniformly across 30 megahertz like you can if you have it mono for one frequency. So I get guys all the time, well, I don't understand, man. Why 4 transistors on 11 meters make 1,000 watts, but when we go and we hook them up in these all HF amplifiers, it's like 500-600 watts. It's all in the tuning of the circuitry. Flat response across a large spectrum of frequency versus hyper mono banding, which is what they do on the 10 and 11 meter bands with their boxes. I think I've explained that in many videos. Listen, I don't judge where people use their equipment. I honestly don't care. That is outside my wheelhouse of giving a shit about. It's just my job to make the amp work. Okay? Now, I've advised the customer that it would probably be a smart maneuver on his part, because I'm not going to even look at this on the spectrum analyzer. I already know what the results are going to be. I'm not even lying about that. I'm not trying to hide behind it. Oh, I didn't know. No, I do know. And I'm not going to look at it, because I wasn't commissioned to do that. I was commissioned to just make this work, to finish it. For me to go and add the filtering circuit somewhere in here and put that all together and find out a way to mount it inside this little case, it's going to be significantly more money. But let's refer back to our reference material that was provided. We meet or exceed these numbers. I consider my day a success. All right, let's jump over to the Henry ss750, and we're going to go back to video footage that I shot 4 months ago when it first arrived here, when I was trying to figure out what exactly went wrong with it. Because it had been running for 2 years. 2 years without any headaches in the mobile. And all of a sudden it started dropping power, and we found out why. So we're going to change. I got to go find that video footage, and through the power of electronics and computers and maybe a little bit of personal blood and semen, we'll get this all put together, and then we're going to come back to this camera, to present day, and we're going to actually do the fix. So we shall return. Okay, now I can say that I'm done. The customer requests I do a positive wire upgrade and do a couple of little things to actually make it a little bit cleaner, which we did, and then I'm asked to install him a fan, which we did. So we're good to go. I'm going to slap the tin on this, we're going to set it aside, and now it's time for the Henry all-band 750. Boom, boom, boom. The customer was insistent that I open this up and I go through it and I start figuring out what's wrong with it so he could figure out how to budget for it. Okay, I get that. So I filmed all of that. I don't know where that video got off to. There's video of me somewhere in the computers over here that I can't seem to find. where it shows me taking this thing apart, and the 40 meter and the 80 meter sections, the coils that hang around the ferrites had wiggled around so much that they were all loose, and they had created cold solder joints. So these bands were incredibly intermittent, and I spent like a day twiddly dinking around with that, like pulling the coils out and filing around the coil, and I documented all of that, and I can't find any of it. So it's like I told him, I said I tested everything, and honestly I don't think you have any transistors that are bad. Well, come to find out, one of them was a little iffy. I'd rather replace the iffy and put one in that I know is good than take a risk. So I just, God, it makes me mad when I lose video. It really makes me upset. I've got like 6 different video cards. This takes 2 different computers to get this pulled off sometimes. At least 3 different cameras that I use. And I've interrogated all of those things. And I can't seem to find the video of me doing the initial analysis, the initial diagnosis, and working through the band board. So what you're going to see next coming up is me jumping in where I go back and I make sure everything is flowed together right, and then I clean the board. I clean all the flux off, because I literally resoldered the whole friggin' thing and made it all work again. So I'm super stoked that we got this to where it's at. Apparently this might be a little bit vibration prone. I don't know what its living environment is, but the guy that owns this is super cool. So I can't see him abusing this, taking into account it doesn't have one more scratch on it than when it left here a couple years ago, and has worked flawlessly for him almost every single day since. So anyhow, I got to throw that little exurb in there so you're not going into this next segment going, whoa, what's he talking about? He's talking about this, talking about that. I kept referring back to the videos that I thought I had on file someplace, which I cannot find. So I dearly, dearly, from the darkest depths of my little tiny black beating cockled heart, I apologize, and I say I'm sorry. Punch me in the eye next time, or give me a swift kick in the baby maker or something to say knock it off. So we're going to proceed forward. Gentlemen, enjoy the rest of this little video. The Henry ss750 brought back to life one more time. Okay, so this is the output tuning board for the Henry, and as we said in the last video when it was here, these 2 caps were part of our problem. They'd come unsoldered. Now it has been 2 months since the previous segments of this video were shot, so I'm just kind of catching back up to where I was at 2 months ago when I was first diagnosing this amp. I went ahead and I went back through and I reflowed most of this again, and then I cleaned it all to clean all the flux off of it, and I think fairly confident if we stick it inside the box it's going to run. So that's where we're at now. So I'm going to start the reassembly process. Come on, man, learn how to speak English. So let me get this slet back on the tin, and let's get this married back up with the amp, and let's see what it does. So it's making power, but it's dragging getting there. So I get the FLIR out and I start looking at stuff. And this transistor right here is ice cold, then his partner is getting hot as frig. Now I swear I looked at all of these things before I got this far, but you never know. Could have had my head completely in my butthole, I don't know. So I'm going to pull that transistor out and check it, because I have a feeling that it is toast. It's definitely not turning on, and I don't see anything else down there that would keep it from not working, so that would explain why things are dragging a little bit. This thing's only making 800 or 900 watts, so that's about what it's supposed to do, but I mean, that thing is ice cold. Just give me a second, we'll be back. This won't take long to do. So it's got a gain of 50. So I reinstalled it. Hello. See the other two transistors turning on. This guy's ice cold. Hello, 1, 2. Very interesting. Hello. Very interesting. So the question is it getting signal to the input? Well, let's grab our silly scope and find out. And the mystery is afoot. Because, let's see here. Back over here. Okay, so I take my silly scope. We're going to measure our input signal. Less than a bar. 2 bars. 2 bars. 2 bars. Interesting. Very interesting. What's it look like as we go off the bleeder pack? No, that's just going to give me a... Let's probe it anyhow. Same. Same. So how many volts is that? 14. It's 4 boxes. 4 boxes. Okay. It's got to be the transistor, but I tested at 50. Interesting. Very interesting. I'll try it again. But I know it's going to give me the same result. If I've learned anything in this game, this busy-o-ness, is once you eliminate all the probables, it has to be the one variable you're not thinking about. So 54 gain. This transistor is dragging behind the others, and I honestly don't believe it's part of the satellite circuitry. So let's go down here to our giant box of transistors. Of course, we don't want to screw nothing up and put a used one in there. Or I mean a new one in there. This one should be adequate. Cool. Gain of 45. Gain of 45. So let's slide this inside the amplifier and let's see what happens. The worst that can happen is it takes off and it runs. Okay. Then we know we've got ourselves a defective transistor. The best thing that can happen is that it does the exact same thing and then we figure out there's something else in the circuit that we have to go look at. But a gain of 50, that's a solid, good transistor. Well, let's put some white hobo grease on this thing here. Rock it down in the hole. Down in her hole. She's feeling so low. Okay. You tell I've been out here for days and days and days and days and days. and days and days, and I haven't left this room. Okay. Okay. For some magic hook together glue. Okay. Let's let that cool off for a second. Won't be the first time. I had this 4-pill that was here one time, and I pulled my hair out trying to figure out what the hell. Everybody's like, it's got to be the transistors. I'm like, they're brand new. It's got to be the transistors. I'm like, it's got to be a cap. It wouldn't tune. It wouldn't stabilize. It was jumping all over the goddamn place. Finally, I changed the transistors, and guess what? Took off and ran. Didn't want to believe it because the pills tested good and everything. Hello, 1 2. Hello, 1 2 1 2 1 2. Okay, same results. Transistor's ice cold. So now, I'm going to trace our signal. Yay. So I crack this nut. I'll be back. This goddamn thing's so hard to make show up on camera. Hello, audio. 1 2 1 2 1 2. Hello. Hello, audio. 1 2 1 2 1 2. Audio 1 2 1 2. Audio. So what it ended up being was there's a 680 and then a 530 cap, and that 530 was junk. It was down in the 300s. Took a few minutes to get that worked out in my little pecker brain that I got, but we got her. So now on 80 meters, that's our 1,000-watt slug. We're on sideband. Hello, audio 1 2. 80 watts in. Hello, audio. 980 to almost 1,000 watts. So makes me wonder what's it doing on 160 meters. Let's go to 160. Come on. Let's go check out the 160 meter band. Hello, audio 1 2 1 2 1 2 1 2. Hello, audio 1 2 1 2. Input's looking beautiful. Of course, the glare of the lights can be wrong. Hello, audio 1 2 1 2. Our output power is looking. Hello, audio. I know a lot of guys that killed have a full kilowatt on 160. Now, where you're going to be looking is going to be all the way down over here, like way down here. Hello, 1 2 1 2. You see it? Hello. That's right. There. You didn't see it? It's okay. I won't hold it against you. Let's go look at 80 meters real quick. They're going to be somewhere in about that area. Hello, audio. See it? It's right. Right here. Hello, audio. This thing makes clean, good, narrow banded power. So, Here's the crux of our problem. Let's go look at the 40 meter band. $40 or $20. It's one of these two it's struggling on pretty goddamn good. Hello, audio. Hello, audio. That's up at 800 watts. So here's 40. Hello. 820 watts or so. Hello. Okay. I'm pretty sure that when I flip this next, come on hands, work with thy brain. Shut that band off. We're going to click this one on, which is 20. I think this is where our problems are going to start. Got our output correct. Get you right in the middle. In the middle. At least a little bit close. There we go. Okay. 20 meters. Hello, 1, 2. There's our 80 watts worth of drive. Hello, audio, 1, 2, 1, 2. So now, let's go look at this. Hello, audio, 1, 2. That's the radio talking through the amp. Hello, over 3. What could it be, George? Well, this is our 10 meter band. And this is our 80 meter band. Or 160. So 160, 80, 40, 20 is going to be here. Let's go play with 10. Wonder what 10 does. So I got to pull that damn band board off again. I mean, as we're seeing with the spectrum analyzer, it's necessary. So, hello, 1, 2. Hello, 1, 2. Hello, 1, 2. Hello, 1, 2, 1, 2. We're good. 700 watts on 10 meters. Ain't the prettiest in the world, but hello, 1, 2. Hello, 1, 2. Hello, 1, 2. Let's go back and play with 20 here. Or I mean 40 meters. 20 meters. Sorry. Hello. Hello, hello. Hello. Hello, audio. Now I wonder if we cheat. And we tell the 7300 to tune to this amp. So go over here to AM, just for shits and grins. Back to sideband. Hello, audio, 1, 2, 1, 2. This is strictly an input issue on 20 meters. Look at that. Hello, audio, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2. That's interesting. So, I can't remember what sequence these relays fire in for what band. This is our input relay. And it's in correspondence with this relay, which is in correspondence with this vacuum relay that's down here. Remember, I had to bypass one of the input tuners on this thing to get it to work right at one point or another. I think we got a confunction at the junction with the relay. So I get to looking, and this wire is just chilling in here, just hanging out. Broke clean off. Now, how much you want to bet that this wire attaches to this relay bank, which has got something to do with the 20-meter control? I'd bet a bunch, because when I tap it to ground, all the relays in the control circuitry go click, 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 and everything changes. So now I get to figure out where the frick this thing attaches to. At least that was easy enough to figure out, I think. Maybe, I hope. Goes right there. Ooh, look at me, world's greatest detective. Okay. So, relay has been repaired. This is with the tuner in line. Hello, audio. No problems, everything's happy. Take our tuner out. Hello, audio, 1 2 1 2. Either way, spectrally. Hello, audio, 1 2. Hello, audio, 1 2 1 2 1 2. Wouldn't be a ham in the world that wish their signal looked like that. Okay. Hello, audio. Let's tuner in, tuner out. Hello, audio, 1 2 1 2. Tuner out. Hello. So it helped us a little bit, but still the input is just way out. Just way out. So I get to looking at the 20-meter band over here. Too close. These two caps are burnt down in the bottoms of them. So we're going to take the board out again, and we're going to test those two caps. And we're going to see what we come up with. Well, gentlemen, we're going to do something different here. A little segment that you're about ready to watch is going to have its very first voiceover on it. And the reason we're doing that is because the microphone for the camcorder is off. Now what I'm doing here is I'm desoldering the disc capacitors. So I'm recording this later, and these video segments are actually really important to what leads up into the next segment. So I'm pulling the two disc caps out because they've got black burn marks on them, which as soon as I get done twiddly-dinking with the soldering iron here and making my beat beaters touch the solder sucker, I'm going to flip the board over here, and I'm going to show you the disc caps after I dismount them from the board. So now if we can get the damn camera to focus, you'll see that the edge of the capacitor is all burnt and black. And this one's got a little smudge mark down by the leg. And this is what I was looking at. I was like, what the hell is this? Maybe this is the reason the output network isn't working right. It's feeding back to the input network. Now I'm going on to explain that there's a little ridge that's on this disc capacitor, and maybe the capacitor's split, and this could be our problems, and I don't know, the values on it, the numbers were all way off. One cap said like 150K on it, which doesn't make any sense for a capacitor. Come to find out it's 150 puff. All right, so we're going to start inspecting the two disc capacitors here. I got them hooked up on my LCR meter here, and it's showing me that this one capacitor that's 56 puff is metering at 57.6, which is acceptable. So now we're going to look at the big capacitor that's got like 150K stamped on it. Oh yeah. It's a little off in capacitance. So I sit here and I talk about this and I talk about that. And I talk about how the value on the front of the capacitors kind of got me a little bit confused. I kind of toss it aside, and I make a reference to the 56K cap that I just had in my hand that was within value range. So Then I start thinking, well, the capacitance is not off that far to make it have that big of dissimilar operations. So this is when I started putting together in my head the idea, formulating the idea that the location of the board, this schmutz that's on the capacitors, might be transferred from that 2-pill section that's in the top left-hand corner there. That 2-pill section's burned up before. So I started thinking, well, maybe this is leftover residue. And if that's the case, clip Bob's your uncle, we can go ahead and put this all back together. So what I don't show here on camera is that I go ahead and I make the decision to change out the disc capacitor because I feel that ridge on the bottom of the cap. And I start thinking maybe the cap might be split or possibly defective. Well, I've got those capacitors. I got 150 puff capacitors followed out my ear holes. So I thought, well, I'll just go ahead and I'll get that changed out and we'll see what the end results are. So this is where I'm explaining when I come back, I'll have everything soldered back together and all the parts will be back in here and we'll have it assembled and we're going to test it. So, well, I've tried everything in the book and tested everything I could think of. I replaced this disc capacitor because I thought it might be cracked. I'm getting good pass-through on all the bands except for 20. The input's hidden behind an attenuator. I'm getting good signal in and out of the attenuator. All the boards are fully functioning, obviously, because they're working on all the different bands. I'm going to simply go with, I don't know. And he's not interested in paying me anymore to sit here and try and figure it out. He just wants to get the thing running, and he doesn't even talk on 20. So at this point, I'm just going to stick with the fact, if you want to run 20, use the tuner in your radio. That's it. That's all I can say about it. So we replaced the input coax, or the output coax. We replaced the transistor, fixed the cap, so we fixed our intermittent power issue. We repaired this wire here, and the band board we had to go and completely reflow it because it was all full of old solder joints that were cold, and all of our intermittent power issues fell out. We're back up to full power again. I just don't understand what the deal is with the input on 20. I don't get it. I don't get it, but I'm going to walk away while I'm ahead. ss750 completed. I'm going to call this one a wrap. Well, gentlemen, this is the end of the tale for these 3 boxes. It's time for them to go home, go back into use. The little RM Italy 4-pill, this TS Systems 4-pill, and the Henry ss750 all-band solid-state 8-transistor amplifier. I don't know what the deal is with 20. I know I'm not going to sit out here for 4 hours and try and figure it out when the guy's already telling me don't bother fixing it, just send the thing back and get her done. So we got the primary issues with that amplifier finished. Now I pray that I can find the video that I shot when this thing initially came in here and I took it apart to figure out what was going on with the band board. I pray I can find that, otherwise this video is not going to make any sense if you're watching it and you didn't see a bunch of other video in there. And sorry, couldn't find it. I know I backed it up, and I know I've been holding on to it. I just don't know where it's at. So I'm going to have to go hunt for it. It might be on one of the 3 cameras I use. We'll see. So on that note, gentlemen, I'm going to run. I have got an unbelievable amount of projects that I need to finish over here. With the global pandemic that's currently taking place, it has not really affected me that much. Of course, if I get sick, then that means I can't work on anything for at least a couple weeks, and that would be a shame. And then, of course, nothing gets to leave out of here for at least a couple weeks. That could put me out of the game for a whole month. So I'm keeping myself pretty locked down. I'm not really going out or doing anything or going anywhere anymore. Hopefully this just kind of slides on by as far as my little house is concerned. But big shout out to Siglant. Big shout out to Excess Power, and big thanks to all of you guys and your continuing patience as I work through this giant mountain of shit that I have over here. If any of you guys know where I could find myself a Henry smoothing transformer of 8K 780 mils or better, I'd really appreciate it. And the only one left in the repertoire that I haven't worked on yet in the line of Henry amplifiers, if I'm not mistaken, is the big Mammoth Jammer, the Henry 8K. The one with the 3CX 3000 in it. If you have one out there that is broken and you don't know what to do with it, I will move heaven and earth to get it picked up and brought here for me to do something with it. So, just putting that out there in the digital ether. Hopefully somebody that watches my videos and is a big fan, the light will come on above their head and they'll be like, I must call BBI. I'd appreciate it if you did. Gentlemen, I gotta run. I got a mountain of stuff I gotta go through. Staying busy, living through global pandemic. I'll see you guys. Bye-bye.